Friends, a single phase transformer creates two circuits. One is from its power supply to the primary coil, and another is secondary coil to the load. And in our traction system, grid substation, from where the supply has taken from two phase, from there to the primary circuit and secondary to our OHE and locomotive and track. These are the another circuit. So transformer has divided our system in two parts, and no connection between the two. So for any failure breakdown, it will affect that side only. For primary, if any fault from transmission to our power transformer distribution, which you can tell power distribution, any failure that will affect that side only, primary to the grid, two phase. Suppose an earth fault, I have shown it here. Before the isolator, before the circuit breaker, if any earth fault is there, it will affect the primary circuit. But if primary circuit power switched off, then secondary power should also be switched off. But we can extend power. That means that circuit, secondary circuit is okay, but power supply will not be there, and it needs power supply, so we can extend it from other TSS. That means secondary has no effect when there is a fault in the primary. Only power supply will be not there, and you can take power supply from the other TSS by feed extension from SP. So it is clear, the circuit will work individually for its failure, breakdown, earth fault, etc., and not will affect the other, others. That I want to tell. It is clear now. So now see the circuit. This is the primary circuit. This is the primary circuit. This is the secondary circuit. I think it is clear to you now. Okay. Now a clear idea about short circuit. What is short circuit? Short circuit is to complete a circuit without load. What is load? Load is one type of impedance or resistance. So when you connect a impedance or resistance, it has some ohmic value. So you know I is equal to V by Z or V by R. So when R and Z is there, so current will be reduced. But in short circuit, this V and Z is almost absent. Very little V and Z is there, so current is enormous. That is called short circuit. Our locomotive is a load. So when everything is closed, loco DJ and our circuit breaker isolator all are closed, then it is not a short circuit. The current taken by the locomotive, that will flow only. It has some wattage or horsepower. So according to that load, the current will flow. But if there is no locomotive and OHE has fallen on the ground, so the R or Z will be very minimum and current will be enormous, and our circuit breaker will trip. That is short circuit. This is short circuit. Directly positive and negative terminal is connected without there is no load. Only the resistance of the conductor of that has shorted the two terminals. So it is short circuit. Immediately battery will be discharged almost. Huge current will flow. This is short circuit. This is short circuit. This is not short circuit because now the two terminal is connected with a bulb and it will glow. As it has some resistance, it will reduce the current and it will not be a short circuit. So direct contact is short circuit for positive and negative, and with bulb it is not a short circuit. In the same way, in the OHE also, if there is load means locomotive, that will in secondary, then it will not be short circuit. But if any parts come in the contact of the earth parts or close to it, because air insulation acts up to 250 millimeter, but if it will reduce more than it, then earth parts to live parts, it will be a short circuit or earth fault. It will be a short circuit or earth fault. So clear idea. With load, it will not be a short circuit, but without load, a circuit complete means short circuit. In the primary also, if your circuit is completed with the partners of primary coil, then no problem. That if your any conductor fallen on ground, immediately it will contact with the grid earth, and it will be a short circuit, CV will trip. So clear about the short circuit. Short circuit is that thing to complete a circuit. Without load. Okay, it is clear, I think now. Okay, thanks friend. Now you can understand what is the short circuit in the 25 kV or secondary side of power transformer. I am showing you. Okay. But maybe loco, the rule of the, maybe the loco is there, yet it will be a short circuit, because the rule of the electricity is to follow the low resistive path, the low impedance path. So loco is having more impedance, so current will flow through the low impedance path, that is short circuit path, if which is directly connect with the ground. Okay, let's see. Friends, polarity of city secondary is very much important. Primary, they are giving P1, P2, though they are giving S1, S2 also, but you check it. Sometimes they can do mistake, and if they will do mistake, then it will create a problem, that is malaporation. So you can check it. But before inspection, I think they are showing it. Okay, but to clear your base, you know the system. You have connected the primary side P1 and P2. P1 is with positive and P2 is with negative. A push button switch is there, and secondary is connected with ammeter. One terminal with positive terminal and one terminal with negative terminal. It is a zero-centered ammeter. Now simply you push and release the switch. If it gives positive deflection and then return to its original position, that means the positive terminal is S1 of ammeter and negative terminal is S2 of the ammeter. But if it gives reverse deflection, that means anti-clockwise direction, then the positive terminal will be S2 and negative terminal will be S1. Simple system. I think you easily find it out. The importance of this system is the connection in electromechanical relay, especially. After that, I have told you already, microserver relay, they already programmed it. You have to fix the particular S1 S2 particular terminal. If you do mistake, then again microserver relay also will will show mal-operation. Will do. That means they have given some guideline what to connect this S1 and what to connect this S2. They have written CT, PT. So you have to connect at that particular terminal. But to understand this, what is the important electromechanical relay connection is better to understand. Next is AC testing. This is the connection of AC test. What they have done, they connect a voltmeter P1 terminal on one side and the other side is connected with any terminal of the secondary, and P2 and remaining terminal is shorted. Secondary one side is connected with voltmeter and secondary other end is shorted with P2. Now if the voltage is giving, incoming side power supply is 230 volt and secondary side is 24 volt. So it is giving, voltmeter is giving the reading of 230 minus 24. Then P1 and S1 is connected across the voltmeter. But if it is giving additive 230 plus 24, then P1 is corresponding terminal with voltmeter is S2. Very simple system. With this you can check the part transformer also, the polarity. So this is the system. I think it is clear. Today is up to this. Next time I will tell the other things also, which is what is revision. Now I am doing revision, which I have given. I have taught you the important things. I will revise again. Okay. So next, after all this revision, we will start overhead equipment. Okay. After overhead equipment, the testing, commissioning, so many things are there. Then locomotive, electrical general, then locomotives. Thank you, friends.